Alrighty. So the first section in Unit 2 is defining functions. All right, so we're talking about defining functions. You can find my last help video up there for the overview. We're focusing on this slide right here. All right. And it's pretty simple to define a function. For something to be a function, each x value must have only one y value. All right. And most of these are pretty simple. It does get confusing towards the middle, so stay with me. All right, so your first example is ordered pairs. All right, and ordered pairs is, as you know, these represent points on the graph. The first number in each case is an x, and the second number is a y. All right, so you've all learned how to plot points in middle school, and we'll be doing some of that in this class too. Okay, so in the last video, we learned that domain is another word for x values. So what they want us to do here is just write out all the x values. Okay, easy enough. -1, 0, 2. All right, there's my x values. Range, what do we got? We got 2, 5, and 7. And range is the y values. Okay, so the question, is it a function? All right, well, each x value only has one y value, right? -1 only goes to 2, 0 is only with 5, and 2 is only with 7. So the answer here would be yes. Yes, it is a function. Okay, next example, tables. All right, tables are pretty easy too. They tell you, here's your x's, here's your y's. All right, for the domain, same thing. We're going to list them out, but we're going to list them in ascending order, so least to greatest. -2, 0, 3. All right, and that's my 3 x values. Now the table shows 1, 2, 3, 4, but 3 repeats, so I'm only going to write it one time. All right, 3 is a 3. Okay, range is my y values. I'm going to do the same thing there. Least to greatest, right? -4, 1, 2, and 6. All right. So big things there. When we list these out, we are not following the order of the table. As you can see, we are writing them from least to greatest. All right. Now, is this a function? Let's see. What was my rule? Each x value must have only one y value. All right. Well, 3 happens to go to 1. It also goes to 6. So this is an example of a non-function. This breaks the rule. Okay, because the same number has 2 different y values. Can't happen. Can't happen. All right. Next example, mapping. Okay. These you've probably seen in a math class before. The x's are on the left and the y's are on the right. Okay. Typically, they're always written like that, x on the left, y on the right. If not, the arrows would just be facing the other way. Okay, but we're going to go through the same process. Write out the domain. We got 3 numbers, -7, 0, 3. Y, we only have 2 numbers, 1 and 2. Okay, it's a little weird as first example like that where they don't match up. That doesn't necessarily mean it's not a function though. Let's see. I'm going to write these out as ordered pairs and see if that makes it a little bit more clear. -7. That arrow goes to 2. 0 has an arrow that goes to 2. And 3 has an arrow that goes to 1. All right. So there's what we got. Okay, now these twos repeat, but that does not mean it's not a function, right? Because -7 and 0 are two different x values. It's okay if they have the same y value. It's okay that they have the same y value because they're two different x values. All right, so let's go back to our rule and see if y'all can see how this works. See if I can just copy and paste that. All right. Okay. So keywords here. All right, keywords here. Each x value. Each x value. That means each one individually. All right. -7 individually is its own x value. 0 is its own x value. All right. -7 has only one, excuse me, y value. 0 has only one y value. The fact that those happen to be the same number does not matter. Okay, so this is a function. Yes. Yes, that is a function. It still follows the rule. Last one, graphs. This is probably the most important one for this class. This is the one that you're going to see the most often. All right. Interesting looking graph here. I'm going to make this bigger. Interesting looking graph. All right, we have a 0. Okay. So this one's going to be different than naming the domain based on points given to me. All right. What I'm going to have to do is look at the x-axis right here. Furthest to the left and furthest to the right. Okay, and if I assume we're counting by ones, this would be -1, -2, -3, -4. So the furthest it goes to the left is -4. If I go this way, the furthest it goes to the right is +1. And again, I'm looking at the x-axis because we're talking about the domain. So the way we're going to write that is -4 is less than or equal to x. And over here, +1 is greater than or equal to x. All right. We will get into this a lot more in the domain and range section, but it's a good preview right now. All right. May actually reuse this video for that. Anyway, so that's the domain, that's the x values. Now for the range, y values. Okay, this time we got to look at the y-axis. All right, the highest point the circle touches right here. So trace that back to the y-axis and find that point. +1, 2, 3. So the highest it goes is 3. The lowest this circle is going to touch will be at this y value, -1, -2. So it goes from -2 to +3. So just like the x's, we're going to write the range from the lowest, -2, is less than or equal to y. +3 is greater than or equal to y. All right, and that's how I write my domain and range for graphs. Circles are not common on graphs, but it's just an example. Basically, we're finding boundaries, right? We're finding the boundaries. We're not concerned with the curve and all that stuff that goes into it. Now, to find a function on a graph, all right, maybe some of you have heard of this. Vertical line test. Vertical, what are you doing? All right, vertical line test. There we go. And a vertical line test is simple as drawing a line through the function anywhere. And if it touches the line more than once, it is not a function. So let's see. Change colors. All right. So I drew a vertical line through it. It is here once. It is here twice. So it did not pass the vertical line test. The answer is no. This is not a function. All right. So vertical line test, pretty simple. Okay. Let's see. I'm going to move this around. See if we can get another example of that vertical line test. All right. So I'm just going to make up a random graph here. All right. And I'm going to draw a quadratic function. Okay. All right, so a U like that. That's something we'll cover in this class. It'll be a while till we do. But if I do the vertical line test on that function, here we go. If I do a vertical line test on this function, let's see what happens. Okay, so I'm going to pick anywhere on the function. Just draw a vertical line. Does the function cross that line more than once? Yes or no? Well, hopefully it's easy for you to tell. It only touches one time. Not females. It only touches one time, so this we would say yes.